Effie? Okay, thanks. All right, so welcome back from our coffee break, just in time for starting our second session, which is entitled Charging the Future. Land transportation of goods and building construction are the two industries we will be looking into today with regards to green initiatives. We will also explore floating offshore wind energy generation as an attractive alternative when it comes to efficient green energy generation. Let me welcome our esteemed speakers of this session. Our first speaker will be Lars Mårtensson, Environmental and Innovation Director at Volvo Trucks. In his 27 years at Volvo, Mr. Mårtensson has spearheaded some groundbreaking initiatives, including the world's first CO2-neutral automotive production plant and a range of eco-friendly trucks. He is a recognized driving force for sustainability in the automotive sector. And we are very happy to have him here with us today. Welcome, Mr. Mårtensson. You can come up to stage. Our second speaker is Michael Chatzigakis, the CEO of Hexicon Power. Mr. Chatzigakis is a seasoned professional with a strong academic background, holding master's degrees from Tufts University and Harvard. He is currently leading Hexicon Power, a Greek-Swedish clean tech company, an excellent example of Greek-Swedish collaboration, which is focused on floating offshore wind generators. Welcome, Mr. Chatzigakis. Our third and last speaker in this panel is Dr. Kostas Balaras, Research Director at the Institute for Environmental Research and Sustainable Development of the National Observatory of Athens. Dr. Balaras has been a leader in energy conservation and sustainable development research since 1995. With, among others, expertise in sustainability assessment of buildings, neighborhoods, cities, high-performing buildings, energy policy, and thermal energy systems. He is the author of over 350 scientific articles. Please welcome on stage Dr. Balaras. And last but not least, I'm pleased to welcome on stage our Session 2 moderator, Kostas Theofylaktos, who is chairman of the Energy Efficiency Committee and General Secretary at the Institute of Energy for Southeast Europe. Mr. Theofylaktos is a senior energy expert with 35 years of experience in energy policy, economics, and management. He has worked in international projects in various regions, specializing in energy efficiency and cogeneration. He has held senior leadership roles in organizations like Cogen Europe and the Greek Center for Renewable Energy Sources. Mr. Theofylaktos, please welcome. The stage is yours. You may begin the session.
Good afternoon, ladies and gentlemen. It's a great pleasure to be here with you, and I would like to thank, on behalf of IENE, the Swedish, the Embassy of Sweden in Athens, and the Hellenic Swedish Chamber of Commerce. It's also a pleasure to moderate a session just after the previous one. It was the best, for us to have those distinguished speakers before and to continue on the energy issues with those three experts. I took a note, and let me see my notes here. Yeah, Mr. Anhilt, in one slide, he said, the future and what is used to be. I'm going to change that one a little bit, and I'm going to say the present. It's also and what is used to be, because I believe that we are living in a very peculiar world. In a world that from geopolitical, economic, energy, environmental, and so on other points of view is very peculiar that moment. Wars in our backyard, in the front yard, economic difficulties in all our countries, in the European Union, with high inflation and so on. High energy prices, huge shock. It was the words that the advisor to the Prime Minister, Mr. Tsafos, just said, and I note that. Embargoes from Russia to Russia, and of course climate change and climate crisis, which affecting all the countries. For example, I noticed that this couple of weeks ago, the World Meteorological Office mentioned that September was the warmest month ever. And now also we have new policies set by European Union, which is leading on the climate crisis regarding decarbonization. Decarbonization with the main milestone in 2050s, but also with milestone in 2030s, where energy efficiency, the further penetration of renewable energy sources, and of course the change and the change of the living behaviors that we have as citizens should be on a front row. So that's why I'm not going to talk anymore. I'm going to say that we have, we introduce an excellent panel, and I'm going to give the floor to Mr. Mårtensson, electrification in Europe and industry transformation. Electrification, which is one of the main pillars for decarbonization.
So, good afternoon, everyone. I'm very happy to be here, and I'm very happy to be able to speak to you about what this, to us, very important topic. Because it is like we heard in the previous channel, we are living in challenging times, and it's also quite clear that on top of the climate challenge, we have many, many other challenges that we need to cope with, both as a society, but also as a company. But as a company, I would say that climate change is probably the biggest challenge because it poses a really challenge to us to transform. And I will share a little bit with you, let's say, how we view this transformation that we are going through as a company, but just as much as we're going through this is also transformation for our industry and also, I would say, for the society. Because even though maybe many of you, I guess, don't share maybe my and our passion when it comes to trucks. Trucks are still crucial. Trucks are a crucial part of the transport system in the society. And the transport system is, as all of us know, the bloodstream of the society. So the transformation we are doing is very much a part of the transformation that happens in the society. And therefore, it's also important to us in the transformation to do this in partnership. And I will come back to that a little bit as well. Obviously, climate is one of the drivers of this change. And at the same time, as we heard in the previous session, climate is maybe not for everyone, let's say, the main reason for making a change. It's obvious to us, and many like us, that this also makes good business sense. The positive thing I would also say that in the climate crisis that we are experiencing, especially, let's say, the severe weather conditions and many, many other things, that there is a strong commitment. Not only have more or less all countries in the world committed to the Paris Agreement, try to limit the increase to 1.5 degrees so we don't get even severe climate consequences that we are experiencing today. But we also have thousands of companies, just like Volvo, that have also committed to the Paris Agreement. And to us, this means that we need to reach net zero in a not a distant future. We want to reach net zero already 2040. And halfway there, we want to reach 50% by 2030. This figure doesn't say much if you don't think about what does this mean. And for us, and I would say also if I speak for our colleagues in this industry, this means very much electrification. Because we see electrification one of the key ways of coping with the climate challenge to take big steps in reducing the emissions and at the same time continue to deliver what transports need to deliver to the society. And our targets that we have set is that by 2030, 70% of our new sales should be electric, both battery electric, as we call it, with batteries, but also fuel cells using hydrogen. So it's not one solution here. And that's also something that I just want to highlight when it comes to trucks, that maybe unlike light vehicles like cars, each truck that leaves our factories are unique. They have been adapted and manufactured to meet the specific need of that customer, that specific type of transport. So there's a tremendous difference if we look at the garbage truck in a city compared with a timber truck out in the forest. And it also means that we don't foresee that there will be one solution that will meet all the different types of needs. Which also means that as a society, we need to understand that for different types of needs here, we also need to support it with different types of energy, different types of infrastructure. And we see three main ways forward. To start with, we still believe that there will be combustion engines also in the future trucks. And more or less all the trucks you see on the roads today, not least here in Greece, but also in Sweden, are using combustion engines. These combustion engines have been developed a lot over the last 90 years. Not only have they reduced the regulated emissions, but also reduced the fuel consumption and the climate emissions a lot. And they have still a great potential. They can be used for biofuels, and they will also be able to be used for hydrogen in the future. So the combustion engines will not die when it comes to trucks. We are strong believers that there will be a role to play for combustion engines also in the future. But there may be more exciting things to speak about, especially with the hype that we see in our industry, is obviously about fuel cells using hydrogen, which will have a great potential somewhere in the future, but also battery electric, which is very much here now. So let me go into this a little bit more in detail. On this graph, you can see a development really illustrating the transformation that we as an industry are going through and we as a company. You can see on the left-hand side, you can see the share of new trucks. On the x-axis, you can see the years all the way up to year 2050. So we're going from a situation, 90 years somewhat, where we have used more or less one type of energy converter, the diesel engine, into a situation now that for the first time ever, we will have less and less diesel trucks on the roads. Instead, the significant growth that will take place now will be starting with electric trucks, battery electric trucks. So going forward, that will be the area where the growth will happen, followed by fuel cell electric trucks using hydrogen. But obviously, there is always a big but at the end of a statement like this. And the big but in this case is, of course, that we also need to have what we call the enabling conditions. Because in order for us to sell electric trucks, we need to have a charging infrastructure. So it's a chicken and egg problem here, because no one will build the charging infrastructure if there are no vehicles to use them. So here is also where the governments and the authorities need to step in. And together with all the different industry actors here, need to come up with the plans how we can make this happening. And I think that is exactly what we see in many countries. Germany is an excellent example where there are very strong focus in setting up the infrastructure, very strong focus in supporting the change when it comes to electric vehicles. And therefore, we also see a very strong development when it comes to electrification in Germany. But there are many, many other countries as well following that path. But I also want to come back to the previous session here and highlight another important area, and that is energy. Because it is not enough with the technology, with the trucks or the vehicles. It's not enough to have the infrastructure in terms of for charging, filling up with hydrogen or biofuels. We also need to have someone who is producing the energy, and this energy should also come from renewable sources. We need to step away from the fossil sources. Because it's obvious to us, if we compare an electric truck with a diesel truck, and if this electric truck is running on electricity from coal, then actually from a climate perspective, the diesel truck is better. So in order really to reach the benefits of electrification, take advantage of this, we really need to pursue also energy from renewable sources. And that applies to everything, regardless if it's a liquid fuel or hydrogen or electricity, it needs to come from renewable sources. And that's also why we believe it's so important to partner up with energy companies to secure that they understand the needs that we see going forward here, both the needs in terms of getting the energy for the trucks, for the transport industry, but also the needs that we see to make the truck in itself more climate neutral, using fossil-free steel as an example. So if I continue a little bit, let's say, making clear that cars or trucks are not big cars. The trucks have very much been adapted for the different needs, and that also means that, once again, as we try to support the transformation here, we need to recognize that for the different type of transport, we need different types of infrastructure and different types of energy. There will not be one solution. So if we look at electric trucks, which is really the core of the transformation going forward here, these type of trucks are today primarily being used for local and regional transport. So if we want to electrify, for example, all the refuse trucks, garbage trucks in the city, the trucks are already here. The good things also with these type of trucks that move locally or regionally is that they don't need to have a lot of chargers spread out over a city. They normally can charge nighttime at home at the depot, meaning that the introduction can start already now. But when we look at the trucks that are driving longer distances, then we need to also to build a charging network along the main routes, or have opportunity charging at the places where these type of trucks would load and unload. So of course, this can sound like a little bit complex, and that's also why it's so important here that this has to be done in a dialogue with the energy companies that need to do the investments in the infrastructure, because as a vehicle manufacturer, we are not intending to do that, but also the authorities, the transport buyers, the hauliers, our customers. All of us need to work together in order to drive this change. And the good thing here is that, coming back to the chicken and egg problem, we are not missing the vehicles. We have for almost a decade now been selling electric trucks. We are today also selling electric machines. Electric buses for more than a decade and electric machines. And now we also, for several years now, been selling electric trucks. And we have now also many competitors who are coming out with their offer when it comes to electric trucks, which is, of course, something very positive in order to drive this transformation. And I just learned yesterday evening that actually we have now sold also our first 3 electric trucks here in Greece. So that means that we actually now also the market leader here in Greece. But 3 trucks are really nothing compared with how many trucks that are sold here. So of course we need to do much, much more going forward. But the positive thing here is that with the vehicles that exist already today, about half of the transports in Europe could already today be done with these type of electric trucks. So a significant part can already today change into electrification, but the other half will continue to rely on the other types of technologies that I talked about earlier. So this change is happening here and now. And it's really a change that also will affect us when it comes to the competences that we are needed. Because in a way, we are also, in terms of our own employees, our mechanics, customers, we're also moving away from, let's say, a knowledge focusing on one type of technology to a knowledge where we need to have much more focus on this type of new technology. Then what I don't have time to speak about, which could also have been very exciting here, since I'm also responsible for innovation for Volvo Trucks, is that at the same time, there are a lot of things happening in automation, in digitalization, connectivity, all the different technology megatrends that exist at the same time here. So this will also drive change. So obviously, these type of trucks and also future trucks will be adapted for many types of trends that are happening at the same time. There's not one megatrend. There are many trends that we need to think about going forward. So it's really exciting times from that perspective. So, but coming back to what is really crucial here, because what we and many with us would like to achieve here is really an acceleration, because it's going too slow from a climate perspective. And it's going too slow also from a business perspective, because we want this to be a significant part of the business going forward. But in order for that to happen, we need policies. We need policies that set out a clear direction. And the good thing, I would say, that if we look at this from an EU perspective, and also if we look at this from a US perspective, what we heard about earlier, I would say the policies have set out a very clear direction in this area. But what is also needed is similar actions on a national level, local level that support this. And then obviously we also need to have this type of partnership that I was into earlier here with the energy companies, with the transport buyers, with many other stakeholders in order to drive this change. Because with this partnership, we can make this change happen much, much quicker. So we are transforming, and I believe that the society will look very different 10 years from now with the changes that we see in the transport industry, both for the transport, for the energy, and for many other things. So it's really exciting times. So by that, I thank you for listening.
Good. Thank you very much. Thank you very much indeed, Mr. Mårtensson, for the presentation. Many of you, including myself, when I've seen the program, I say, how they are going to be connected, all that. In the previous slides, Mr. Mårtensson fulfilled that. He said, what we need green energy, I recorded, power grid, and charging infrastructure. So, based on that, and because you need power grid, so I called to the podium Mr. Michael Chatzigakis about the floating offshore wind. The floor is yours. Thank you.
Firstly, I want to thank the Hellenic Swedish Chamber of Commerce and the Swedish Embassy for organizing this great forum. And I personally want to thank His Excellency Ambassador Borgström and Ms. Rania Pachapoulou for their significant efforts in promoting Greek and Swedish business collaboration all these years. Now, what I'll try to do in this short presentation is I'll try to explain what offshore wind is, focusing primarily on floating offshore wind is, why it will eventually become the next big thing when it comes to renewables, what are the prospects in Greece and abroad, and what role can Hexagon hopefully play, what leading role in this transition towards a greener economy, towards a greener energy. So to begin with, what is offshore wind? So when we talk about offshore wind, we usually mean two things. We mean the fixed bottom and the floating. And there are two very much different technologies. Now, the fixed bottom, as the name suggests, are wind turbines that are fixed at the bottom of the sea. And these wind turbines are placed on shallow waters, not more than 50, 55, maximum 60 meters of depth. Floating wind, on the other hand, is when we place a wind turbine, or in Hexagon's case, two wind turbines, on top of a floating foundation. And that can go into much larger depths, and therefore we have more potential. So one question that I often get asked is, why do we need one more variation of energy. We have onshore wind in our mountains. We have a fixed bottom, and now you're talking about floating wind. So why do we need floating wind? And that's a good question. We need floating wind for several reasons. And for the interest of time, I'll mention the 4 most important here, but there are more than that. And I think these are the reasons that will make floating wind the next big thing when it comes to renewables in the decades to come. So the first reason has to do with demand. There is a very high demand for wind, and that will exponentially increase as we move towards net zero. And simply put, the supply from the onshore and from the fixed bottom is simply not enough. There is a big area up in the North Sea where you usually see those fixed bottom wind farms, but the reality is we are running out of shallow waters there. And in fact, there are very few available, limited, suitable areas for fixed bottom. In fact, more than 80% of the seas worldwide are deep seas. And deep seas mean floating wind. Now, the second reason has to do with the environmental conditions. So the further you go from the shore, the higher the wind speed and the more stable the wind speed, and we need both. Higher wind speeds translate into more energy production, that is kind of self-evident, but stability is also important because we need consistency and predictability in power generation. And one important metric, among others, that show the effectiveness of floating offshore wind is the capacity factor. Now, the capacity factor tells us how much of the maximum total energy that can be produced is actually being produced, and the capacity factor for floating wind is about 60%. And for onshore wind, it hovers around 30%, and for solar PVs, it's about 15 to 20%. So you see 20, 30, 60. So there's a big difference there. The third reason has to do with the environment. And of course, there is a minimum environmental impact footprint when it comes to construction and maintenance phase, but we have some good news also, because according to recent studies, floating wind can create artificial coral reefs that really enhance biodiversity and enhance marine life. And according to the United Nations Environment Program, more than 1/3 of marine species live around coral reefs. So potentially, we can have, through the floating wind, a potential positive environmental externality. And the fourth reason has to do with public approval. So we have presence in more than 10 countries, so we see support from local communities, but I think it's better if we see that in reverse. So far, we haven't confronted the classic not in my backyard problem, which we very often see with onshore wind, which is people demonstrating, sort of revolting because of the wind turbines, and eventually that can lead to long delays and even cancellations of projects. So far we don't have that, and there are various reasons why we don't. I think the most important is that the further you go from the shore, the less visible the wind turbine is. So people from the shore actually cannot see the wind turbines. And if they cannot see them, they don't complain about those. And I think those 4 reasons will lead to a remarkable market acceleration as we go forward. And in fact, this market acceleration has already started. And Mr. Nikos Tsafos touched upon that very briefly in his previous presentation. Europe is quite strong when it comes to offshore wind, especially the Nordics, England, and Scotland. We lately see Asian countries aggressively pursuing policies in favor of floating wind, and in particular Japan, Taiwan, Korea. They are very strong in pushing forward floating wind. And lately the US is trying to catch up, but it is still a couple of steps behind. Now, I believe the potential is really huge, but we still have the challenges, and there are several challenges. I'm assuming we will further on talk about those challenges. I think the 2 most important ones for us is the risk associated with a technology that is, yes, effective, but is not yet as mainstream. as onshore wind is, or even as fixed bottom, and therefore a higher, a less tested technology results into higher risk. But from the other hand, from an investment perspective, a higher risk also entails a higher reward, especially for an industry that is on the verge of commercialization. And the second big challenge has to do with our cost structure, and our life gets more complicated with higher interest rates and more persistent inflation. But we are generally, even though we have advanced and progressed over the years, we're generally more expensive than our fixed bottom and onshore turbine cousins. And now I'm going to shift gears a little bit and talk about Greece, because I really do believe that Greece can become a hub of offshore wind. And we have natural advantages, we have physical advantages that are very important. To begin with, we have some of the best winds, some of the strongest winds in Europe. We have an extended coastline, and therefore many places that we could put and create those offshore wind farms. And for the most part, our waters are deep waters. So something like 80 or 90% are deep waters, and therefore we have a lot of potential. And according to a recent study I read, the maximum that we could produce from floating wind is 40 gigawatt, which is by itself alone to supply, to cover the entire country's electricity needs and even export. So the potential is there. Now, the first legislation bill passed a couple of years ago, so hopefully we see the appetite from the government pushing that forward and setting lofty targets. And also we see the support from the European Union, both funding-wise and policy-wise. So in a nutshell, all the ingredients are here with us. We just now need to play our cards well to make Greece a hub for floating offshore wind that will eventually create thousands of jobs and add value to the economy. So I think that goes beyond the industry itself. Now, let me very briefly talk about who we are and what we do. So Hexicon Power is the Greek subsidiary of Hexicon. Hexicon is a Swedish company that a couple of years ago joined the Stockholm Stock Exchange, the Swedish stock market, and we've been operating for about 15 years. And that makes us, believe it or not, one of the oldest companies in the field, which is very telling of how nascent, of how new this field is. We have a dual business model, and that's part of what differentiates us. So we have two hats. We are both a project developer and a technology provider. Now, when it comes to project development, we engage from the very early outset in identifying, in finding the right market, then spotting the right sea areas, and then designing and developing these sea areas in order to be ultimately investable. And of course, different legislative approaches requires some kind of flexibility, but we focus on early stage development. Now, if you take a helicopter view and try to see the market, you will see that there are many large and small offshore wind developers. But they only do that. They only focus on that. They are technologically agnostic. They don't commit to a certain technology. They don't own a certain technology. And on the other hand, you will find a number of 60 plus of technology providers, companies that only provide the technology. They engage in no other aspect of the project development. So we do both. And there are significant synergies and advantages in doing both. It's the obvious one that by doing the project development, you enter new markets. And by entering new markets, you have more opportunities to put your technology into practice and improve your technology, but at the same time, get revenues because we have a license model. But the reverse is also true. The fact that we have one of the most cutting-edge, innovative technologies also opens doors to form new alliances, new partnerships. So kind of one helps the other, and therefore I think we have a more sustainable business model in the longer term. And with this business model, we have a presence in more than 10 countries around the world. primarily focused in Europe because we believe Europe has the highest potential, but we have expanded elsewhere. In fact, our largest project is in Korea. It's a 1.3 gigawatt project. We're doing it in partnership with Shell. So Royal Dutch Shell has 80%, we have 20%, and we are seeking new opportunities to expand elsewhere. So because I'm running out of time, before I close, I want to say a few things about our technology. So our innovation is that you put 2 wind turbines on top of a single floating foundation. And that is important primarily for 2 reasons. One is that by having 2 wind turbines instead of 1, on a certain sea area, on a certain sea plot, you can produce more energy. Okay? And that going forward, as we move into commercialization, that is important. But at the same time, exactly because we have 2 wind turbines on a single floating foundation, we use less cabling, we use less metal, we use less of a lot of things, and therefore we are more cost efficient. So we are able to produce more energy more efficiently at a less cost per megawatt hour. And this is how it works. So there is a triangular steel structure, okay? And that's quite big. It's 170 to 100 meters, so it looks small, but it's quite big. And on the left hand and on the right hand top corner, you have the wind turbines. And on the middle, underneath that, you have the mooring system attached to a turret. Now that helps the platform rotate, and therefore it can capture wind from whatever side it comes, and therefore it can capture as much wind as possible. And I'm running out of time, so I'm going to pause it here. I think it's a very high potential place to be. We are talking about an unlimited, untapped resource, and I hope that going forward, governments will also support this effort if really they want to walk the walk and pursue renewables and they really mean what they say. So thank you very much.
Thank you very much, Mr. Chatzigakis, and thank you very much for explaining a subject that is not very well known for a lot of even the engineering world here in Greece at least. Now the third pillar, as Mr. Chatzigakis was renewable, is Mr. Konstantinos Balaras, assessing sustainable solutions for the built environment, buildings. Very difficult issue towards decarbonization.
Thank you very much. Good afternoon. It's a pleasure being here and having the opportunity to share with you parts of the work we have been doing and of the issues and the challenges we have been trying to address. And when we're trying to put in perspective what we're talking about, let's talk about some numbers. I'm an engineer. I like to communicate with numbers. And some takeaways, if you want to quantify, how important is this topic? Well, 40% of the energy we use goes to buildings. About 30% of the emissions to the environment are related to buildings. Wow. So the challenges we're facing are related to a sector, the built environment, that gives us the opportunity to address in order to be able to handle the global issues, the environmental issues, the energy issues. But what makes it more interesting to make our lives better? At home, at work, at our office, at our business. It's all about the buildings we live and work and what we're actually paying to operate. So realizing that this sector has to be handled and it has the challenges, it has the opportunities to be able to address these issues. The EU has committed to meet these challenges by setting targets, specific targets, that actually are evolving being legally binding, which means it's the law. And we have to actually commit and actually reach these goals. It's not just a scientific, technical discussion. What sets the stage at European and also global, but also national level, and what drives this process are the emissions, the greenhouse gas emissions. So the EU and all EU member states have committed to reducing and setting these goals to over half, as you see here, tomorrow, 2030. That's tomorrow. Over half of the emissions, we have to cut it. And then there are supporting directives, regulations, talking about energy efficiency and renewables that actually are providing the means to achieve this commitment. Just a few days ago, the new European directive on the energy efficiency was released, setting more obligations to all of us, to all member states, to achieve these goals and targets because, hey, we know where we are up here. We know where we want to go by 2050, which is calling for the decarbonization of our continent, of our countries. Is that going to be easy? No. Look what we need to achieve. So these efforts, who's going to be driving, who's going to be providing some solutions? Most of the plans are calling and pointing to the buildings. That's where they're expecting to gain the benefits. That is putting a great challenge and a great opportunity because there's business, huge business, because we're talking about millions of buildings, billions of square meters of existing stock that has been a great investment, both financial but also culture. It's a great value. The numbers say about 70% of the buildings that would exist in 2050 that would have to really be high performers exist today. Wow, I have the problem that I need to solve right now. So I need to be doing something, so there are the opportunities. The challenge there is financing. How we're going to be financing this business. Now, we know another path that will move us forward. Everybody's talking about electrification. That means we need clean, that's the key word here, green is another key word, electricity. But it cannot be an abundance of that. We don't have the infrastructure, we cannot afford it. The other day I was challenged, hey, if it's going to be green electricity, why do we care? We care. Energy efficiency is number one. It's the first priority. The best natural resource of different forms of energy is still the energy we don't use. So energy efficiency, energy conservation is the first step. We need to reduce our demand and waste, providing for our buildings to live in and work in. We need the appropriate environment to do all this, but we need to minimize waste. And the energy, the idea, the concept is, it has to be clean. So we're going to be crossing out the combustion for the operation. If you're burning, and it's common in Greece to burn oil, imagine you have an oil tank in your building and you burn it to heat your house, or natural gas. That is going to be outphased, and then that brings out part of the problem. It removes it from creating emissions at your building because you're burning a fossil fuel. But I need energy to operate my buildings. Where's it going to come from? Well, different forms. We want some distributed and local generation from renewable energy sources. That changes a little bit the idea of how we design and set up the whole system. Interconnectivity, yes. We need key here to all this, storage. And we need to be careful because we don't want to start creating other problems, environmental problems. For example, with batteries. And I recognize, I don't know if you read the posters inside where Swedish companies are working on recyclable batteries. Key challenge. We must be extremely careful not to create future issues, problems with the environment trying to solve something else. Already, for example, in California, they have a huge problem with all the waste from where? Renewable systems, photovoltaics that are being removed, and they end up not being properly recycled because the market cannot absorb that. So the same thing with batteries. Need to be extremely careful with that. And we need the brains. We need the smart buildings, the smart cities, in order to be able to handle all this with our network and our use. But tell you what, if we look at the future, probably we're having an easier problem right now. It may sound weird, what I'm talking about, because we need to be sustainable. What is emerging as a more global issue is sustainability. And if I would challenge you, say, what comes to your mind first when I'm saying, what is sustainability? What's a sustainable building or city or whatever? You would come up with different ideas, perspective. Are you right and wrong? You're right. And I just tried in this slide to just throw some of these concepts there because that's what sustainability is. It's not about energy, not about emissions, not about environment, not only about economy, not about social, it's everything together. Wow, now you're making it impossible to handle. Well, that's the challenge because that's really what we need to be addressing and doing for engineers, for other stakeholders, for the cities to be able to handle this. We have different systems and methods. We have different indicators, like your car. What's the mileage on your car? How much fuel you consume per kilometer? The same thing. How many, for example, waste you generate? What about your transportation? All these issues, how do I handle this complex? Well, there is a plethora, of course, of ideas and challenges, and especially once we start increasing the scale, going from the building to the neighborhood to the city. Now, how do you actually address this? Already, the EU, in this direction, this concept, has introduced a system, levels. It's going to come in our reality in the engineering world. When we audit buildings or design and construct buildings, we'll have to observe these new restrictions in terms of limitations we have for the different parameters we need to address. And there are also commercial tools and systems. What we have tried to develop, to offer to engineers, cities, municipalities, people to work in this direction is an open free system that has been designed in order to be able to help and support all these different facets, aspects, from the building up to the city. And you see, of course, the different parameters and different issues, as I said, from the energy, from the environment, from the transportation, including, for example, resiliency. How do you actually quantify or try to describe in this complex system all these issues? That's how it works. And how do you manage to communicate this information, have developed also all this educational training material that can help. And at the end, we need to be able to come up with something that we can communicate to the people, to the, for example, the authority, financing or prioritizing scenarios for renovations, for involvements, and so forth. So we have a tool. I don't say, oh my God, there goes a guy from research and education is trying to put aside. No, what I'm trying to tell you, I'm not going to get into details, but I want you to be aware that, oh, I have a tool, so I can do something. It's doable, it's workable. It has different versions. It's not just available in different languages, which is sometimes good. It has been adapted to the local priorities, to the local information, all integrated in there, and it's open source. So this is something you expect. I work to a public institution as a public service to be able to offer something that is open and free to be used. Here's the big picture. What it stands in terms of, again, a takeaway. It helps you, it supports you from the design, the concept, down to the implementation and the monitoring. It helps you make the decision-making process easier. And while doing all this, it engages the people. It engages the citizens. It engages us, because that's part of the process in order to be able to be successful and operational in terms of what you envision, decide, start implementing, and monitoring. How successful are we in terms of the results? There is a motto: we think globally, but we act locally. Somehow we need to bridge this process, because it's down to us to be able to do and implement these concepts. This is an interesting slide just to tell you that, okay, sometimes theory is good, talking about it is good, but what about implementing, doing something? Well, we have test drive it, the whole process, the whole concept, and as you imagine, the tools have been adopted by some of these cities, and you notice both South European, but also in the North Africa and Middle East. We're trying to see and verify that these concepts, methods, tools are applicable and doable. And with that, I would like to thank you. I think I have made to complete my presentation on time, and maybe we have some interesting discussion. Thank you.
Thank you. Thank you, Dr. Balaras, for your informative presentation on the issues regarding buildings. Now, I'm going to change a little bit the procedure, and I'm going to ask the audience if they have a question. Let's start from you, and then we'll go to questions that I have in my mind and we discussed before. So, anybody? There is one. You have the, okay, I'm sorry. All right. Please, your name and...
My name is Amanda. I'm from the Embassy of Sweden. I'm just curious about the role, potential role of hydrogen as a storage for energy. Perhaps it's more relevant for Volvo. In the fuel cells, I mean, there's alternatives with cooling and with ammonia.
I would say the short answer is that we definitely believe in both hydrogen as, let's say, an energy carrier on vehicles, but we also see a connection to wind power here. So I will hand over the mic here just when I finished here. So it's definitely so that hydrogen has many win-wins, I would say, not only for vehicles, but also, let's say, to manage the capacity challenges that we see in the power grids, but also when it comes to renewable energy as well.
I think hydrogen has a lot of potential, and it will eventually play a role. And it is it's not at all prohibitive to energy. If anything, it is supportive. But I see we still have a long way to go. So we still have a lot of kilometers to, it's a long distance. My focus would be at this moment to tackle the big challenges that we have when it comes to wind, which is the #1 renewable resource, in order to be able to promote it, so for the consumers to have cheap energy and clean energy. So that would be my focus.
Also, if I may say that on your presentation, Mr. Mårtensson, I noticed that you have liquefied methane, bio-LNG, biodiesel, hydrogen. So there is an order that we should follow in a way in order to reach hydrogen level, and where hydrogen is going to be the one carrier that we're going to use. So we have to pass through stages, I think.
I think to start with, we believe that the different energy sources will complement each other. And for example, we have today a cooperation with a windmill manufacturer that is looking into the possibility to, let's say, in connection to the windmill, also to produce hydrogen and store the hydrogen, and then we can use it in the trucks. So I think we see synergies here. Then, of course, it's a matter of time here as well, and it also has to be cost efficient. But we strongly believe there are many win-wins when it comes to hydrogen.
Okay. Costa.
It is. Did I do this?
No.
Okay. It is one of the solutions. We have many, and it's one of them. It is environmentally thinking. It is a great fuel, because what do you get out of it? It's water. So what's the problem? It's the amount of energy it needs to be produced, generated. So once this gap is resolved, I think we'll have an excellent perspective, even also used to cover the energy needs in buildings.
Okay, that was a very good question, because he moved us to the questions that I have in my mind. You presented technologies and methodologies, and I would like to ask you, how mature, meaning that how easy it is a common person to use it. For example, electric trucks, we need transportation. I mean, is it mature to have an electric truck for Athens to go to Stockholm? Let's make it like that. And of course the technology is there, I understand, but do they have so many electric, how you call it, yes?
I think I tried to make clear that, let's say, electric truck are today primarily suited for more local and regional transport due to range, but obviously there is, in theory, it should be possible to drive from Athens up to Stockholm using, let's say, the charging infrastructure that exists, both for trucks but also for cars. So in theory it's possible, but I don't think it will make business sense, not yet at least. So in the future there will be, let's say, opportunities, but also for this type of longer transport, that is maybe where both biogas but also hydrogen will come in the future. So once again, the different technologies and also different energy will complement each other. There will not be one solution for everything here.
Okay. What about the FOW? Now I got
The floating wind, okay.
Yeah,
So, floating wind technologies, and I use plural because there are many variations of these technologies, are maturing at quite a fast pace. They are advancing really at quite a fast pace, especially over the past decade. But I would say they are not yet as mature, they're not yet as mainstream, if you will, as onshore wind is, or even our fixed bottom cousins. But because we are on the verge of commercialization, and I hope and I expect to see commercialization be reached by the end of the decade and the first gigawatt projects, I think we will reach that maturity phase by the end of the decade. But we've already have seen signs of the technology's effectiveness, both on the benefit to the environment. I mentioned that, you know, you can have a potential positive environmental externality, but also on the energy output. And I mentioned the capacity factor. You know, we have about 60% onshore, 30, solar 15 to 20. So there's a big gap there. And I still believe that there is still room, plenty of room for improvement. And so when it comes to floating wind, I would bet long.
Okay. Just for curiosity, the Koreans, because you had it in one of your slides, the Koreans, how far ahead it is compared to us?
Well, us meaning Greece, because that's very much ahead.
Greece, but Europeans.
European. So the Koreans, because they mostly have deep waters, they are very aggressively pursuing policies for floating, and they are cutting off red tape and bureaucracy. So if I had to bet, I would say that the first gigawatt plus project would be in Korea.
Okay, that I wanted to hear.
Yeah.
Costa, do you want to add something? All right.
Well, the technologies are there. The information is there. The solutions are there, and the industry has been responding and keep it improving. The market is full of possible solutions. So where's the problem? Well, the problem is financing all these renovations, the retrofits that we need in our buildings. So the big challenge is to be able to support the building owner, the business owner, to be able to implement these possible solutions.
Okay. You're working many, many years, as far as I know you, on smart buildings, and you had a very nice slide, the building, the neighborhood, and then the city. Why we don't have anything, I mean, real, except very few exceptions for a smart city in Greece, for example?
Because it's not easy. It's very
that.
challenging. And the complexities of the smarters are just emerging. Up to now, you didn't really have to be smart other than some building management systems at your own. But now, you're going to be interconnected. Now, you're going to have your neighborhood buildings, and maybe your city, and maybe your local network. And we need to be able to respond to the different needs, to the different loads. So all this automatically now raises the bar.
Okay.
And that is going to bring in all the other smartness facets. It's not just controlling your equipment, it's not just controlling it's controlling your transportation, it's controlling when you charge or discharge a battery in your car, for example, or be able to facilitate the information about traffic, so it will give me the best route to reach my point. Things that we already start getting a taste of it, even with our just applications we have on our cell phone. But bringing and connecting all this, imagine who's going to really get the first kilowatt hour, the first electron that is available. Who's going to prioritize it, get it?
Yeah. As he said, the first, yeah, okay. So, therefore, let's talk a little bit about the key challenges. And regarding the key challenges for the wide-scale adaptation of such solutions and frameworks. Can we learn something from you, from Sweden? I mean, how deep you are in electrifying your tracks?
I would say that, to start with, something that I didn't mention is that the transport industry is quite a conservative industry. So in order to drive a change, you need to be able to prove that the solution is working. And one thing that I believe is a strength in Sweden is what is called triple helix. It's a cooperation between universities, authorities, and industry. So in that type of context, we have cooperated with others, and we have, let's say, set up demonstration projects in big scale, and we have been able to prove to our customers and others that this is actually working. So demonstrators are really, let's say, key to show to others in the industry that it's working, and then we can scale up.
So in our case, there are several challenges. I don't know where to start. I think perhaps the most important is the costs, and especially now with persistent inflation, with all these sort of bottlenecks and the high cost of capital, I think it makes our life harder. So costs is one, and I think we will be able to drive down costs when we scale up. Scale is going to be a big advantage for us, and when we move innovation away from the wind turbine, which it's been innovating a lot, but also to the floater and other parts. But beyond that, around floating wind, a whole new ecosystem is being built. And there are many challenges there that also obviously create bottlenecks for us. So for example, there is a weak port infrastructure, which is important. We don't have enough shipping vessels to transport the floaters to the locations. We have a shortage of powerful cranes to lift this very heavy steel structure. And even some of the components, because we have a deficit in the components, we have to order them from China and Asia and elsewhere, and so on and so forth. So we are in a difficult situation, but I think if we are going to walk the walk and reach net zero, as we have said, we need renewables, and honestly, floating offshore wind is an unlimited, untapped resource, and it will be a game changer. And I think, with all honesty, now I'm in floating wind, but with all honesty, I think the potential is huge, the upside is huge, and the opportunity is now.
Okay, let's assume that leftai υπάρχουν. We have the money. Okay.
That's a good assumption.
That's no problem about that.
Yeah.
Do you believe that it's easy to install 1 megawatt of FOW in Greece tomorrow?
Well, tomorrow it is hard because these things take time, and there is a lot of bureaucracy. And even if we wanted, to do that, we, as I mentioned, the supply and the other bottlenecks, we, for example, need the energy grid.
Yeah.
So
no
we need, even
yeah.
if we can place them on the water, we need the cable to transport
Exactly.
the energy. So so it's the whole ecosystem,
Exactly.
okay, that we have to deal with.
Exactly.
And,
Yeah, you're right. Yeah. That I was trying to emphasize the lack of power system, not only for Europe, even for new onshore wind and renewable in Greece.
If you had the money.
If
you had the money, you could install the infrastructure, the new grid.
but you have bureaucracy.
Right, that's what I want to say. So the issues about policies, and not just setting the law and the regulation, but enforcing it, monitoring, has been a big challenge issue. And even at the European level, and every member state has different experiences and issues, we have huge problems in Greece. We have so many laws, but we need one law that says you need to follow the law. So that's really part of the challenge. But I don't know if I emphasized enough. Even the new energy efficiency directive that came out a few days ago, it now has legally binding, which changes the game, because now there's going to be enforcement, monitoring, and then obligation to do something about it. And in our area, like I'm a mechanical engineer like you, we need to be careful not to replicate, blindfoldedly say, well, yeah, building, yeah, we're going to do A, B, C, and D. No, maybe it's A, F, and Z in terms of the solution. It's not the same order. It's not the same applicability to everything. And maybe that's one of the most common flaws, failures that have come up over the years with all these technologies. Everyone would come up and say, you know, you preach about solar air conditioning, for example. We tried in our building and it failed. Well, I can tell you why if I look at the decision-making process, the design, the implementation, why it failed. So even the most attractive technologies, solutions out of this big list do not apply and work in every building.
Yeah, you are absolutely right. For example, I've seen a lot of Greek schools that now what they're doing in old buildings, 40 years old, things like that, installing PV. So we have green electricity, but the kids in December, January, February, they're with their coat like that, trying to learn things. Impossible. So first you make the building to be a real one, a building without losses, with thermal comfort, and then you introduce photovoltaics. It's exactly what Costa said. It's not all the solutions the same, depending. So now, I would like, as the time is, to you, Lars, because, you know, I'm a little bit, you are ahead of us anyway in a lot of things. You've seen it also from the slides from Dr. Balaras, that Sweden was really down regarding emissions and so on. Yeah. What is the national strategy that you, as a Swedish society, you implement years ago, I believe, on issues in order to reach now to have, for example, electrification in the trucks, in the cars, in in that area at least? What is what we need to do for us? What are you going to advise us to do?
Well, I'm not sure I have a good answer to that, but at least I can reflect. I think one of our strengths, both as a company and also as Swedish, I would say that we always have been quite close to the nature. We have always been quite aware, let's say, of the impact that we can have on the nature as well. And I think that has helped us quite a lot to think about, let's say, the steps that needs to be taken. Then on the other side, maybe also make a comparison with what I've heard about Greece here. I would say that also Sweden has also some things that are got for free. We have a lot of access to water power. We have a lot of opportunities when it comes to wind power. So the access to renewable energy is, of course, a strength that we have had, and we are, of course, also taking advantage of as a country. So I guess that each country, and that's also why we as a company see that we need different approaches. Each country have their strengths and the weaknesses. And when it comes to renewable, I think it's really, as we have been into, an untapped potential. And I think that has really helped us as a country. And I also think that is also one reason why many global companies are now allocating their production of batteries or data centers to Sweden due to the access of renewable energy. So of course that's also one of the many opportunities and win-wins by investing into renewable energy.
Thank you. Mihaly, you're working with a large Swedish company. If you have to advise the Greek government on that issue, what are you going to say? What are you going to propose?
So let me think, where can I start?
You have 5 minutes.
So I think, let me start from the European level, because some of the challenges are common. Sweden indeed is ahead of the curve and very decisively pursuing green energy and renewable energy. So the current national strategies in Europe I think are outdated, because we are facing a new landscape, different circumstances. We face higher interest rate, higher cost of capital, a persistent inflation, and as I mentioned, multiple supply chain bottlenecks. And it's very indicative that last month there was a big auction in the UK for offshore wind. And you know how many bids it received? It received 0 bids, 0. And similar results were seen in Germany and Spain, which is a huge blow for the renewable strategy. So for some reason, maybe political, maybe lobbying, maybe others, some governments are backtracking from renewables, and that is very dangerous. But I think going forward, what we must do, and the Greek government has to do, is to take a more holistic approach in terms of designing a strategy. It has to, of course, address the pricing scheme, because at the end of the day, for a project to go forward, it must be financially viable, so that is very important. But we need to go beyond the pricing scheme. We need to address those challenges like the energy grid, the red tape, easing the permitting phase, which in Greece we always have problems with that, even support our port infrastructure and other kinds of infrastructure. So yes, pricing is important, but we need a more holistic national strategy.
Costa, what's gonna be your advice to the government, to the authorities, to the Greek authorities, in order to promote energy efficiency in the building sector more efficiently? What's gonna be?
Well, they already know what they need to do, and they have made some good strategic decisions. In Greece, there's a clear commitment for renewables. We have already been phasing out the lignite power plants. You see this in the numbers. Now, unfortunately, with all the issues and the challenges we were discussing in the previous sessions, there was a rebound. Already we see that in the increased emissions, because we fired up, like the rest of Europe, our lignite power plants. But overall, the policy in the right direction. What is still missing, though, is in terms of the implementation of the renovation. We're not moving fast enough. The national programs that need to be in place to support the homeowners and the businesses in the tertiary sector with the renovation are moving at a very slow pace. It has been over 3 years now that we haven't seen a new program. And we need, if you notice this downtrend, this is not theory. This is not a curve that can, we'll see. It's now becoming a legal commitment that we all need to be able to comply with this path that the EU has committed. And at the national level, we also have a new climate law that says the same thing at the European level. And if anything, I would also encourage the state to think of the priorities in terms in helping our national industry. For example, it only was about a few months ago that they brought in a program to help support solar thermal collectors. Imagine one of the really strong industries in renewables in Greece is solar thermal collectors. It took years to really support, and we still have thousands, millions of households, of public buildings that could, it's a no-brainer. I mean, it's not first priority, it's zero priority to have a solar thermal. And it's only been recently to introduce this. So some things that make perfect sense need to actually just go down into implementation.
Yeah, at the same moment, they're having programs changing the refrigerator, which is about 350 kilowatt hours per year, compared to the hot water, which is thousands of kilowatt hours for a simple family of 4 people. Nevertheless, I don't know, the last 50 seconds, I'm gonna thank all of you. You have a very informative team. I learned a lot personally. I hope also the audience learn a lot. And I would like to thank personally the Hellenic Swedish Chamber of Commerce giving me the opportunity to moderate this session. Thank you very much indeed, and have a pleasant afternoon, and looking for the next session. Thank you.
Thank you so much. Thank you very much. It has been a really insightful discussion. There is a lot of things we all learned about that. So time for our second coffee break. Please accommodate yourselves. Please be back at 8.